All right, so welcome to another episode of How Do We Pass Our Common Core Algebra Regents and got you. All right, so in this episode, we are going to do something that you already know how to do, but we're going to call it differently. Solving linear quadratic systems. You already know how to graph a system of equations. Okay, linear equations. The system of linear equation consists of two equations, okay, two lines like that. And, you know, one line going one way, the other one. And the solution is the point of intersection. We got that, right? Well, the same thing happens in a system of linear quadratic equations. So I'm going to show you how to do three different methods today using algebraic way and graphically. So let's say we have the following. Let's say we have an equation of y equaling x squared minus 11x, okay, minus 36. Let's say you have that. And let's say you have a linear equation, y equals negative 12x, okay, plus 36. The first method that I'm going to show you is called the substitution method, which you already know what to do. Take any of the equations. Choose one, top or bottom. Hurry up. Okay, so you chose the top. That's fine. So let's read it. Y equals x squared minus 11x minus 36. So whenever I say y, you say x squared minus 11x minus 36. Y. X squared minus 11x minus 36. So this is y. Wherever I see y, that's what I'm going to say. So look, I see y right here. Coin, toin, toin, toin. So that is what I'm going to replace this with. Okay, so now, in other words, I'm going to set the equations equal to each other. So now what am I going to write here instead of y? You got it. X squared minus 11x minus 36. I wrote it. That's y. And then the equal sign. Okay. Equal sign is, what's the other? Okay, negative 12x plus 36. So you stop right there. And you ask yourself, what is this? Well, this is a quadratic equation in itself, by nature. So all quadratic equations must be set equal to 0, so that's what we're going to do. Okay, so I'm going to make this side equal to 0 because, look, my x squared is already positive. If it was negative, then I would make this side equal to 0. So how do I do that? Easy. Add 12x, okay, to make it 0, and subtract 36 to make it 0. And what you do to one side, you do to the other. Okay, so plus 12x minus 36. Alrighty. Now, let's write what we have left. X squared, negative 11 plus 12 is 1, so plus 1x. Negative 36 and negative 36, that's negative 72. And on the other side, what do I have? 0. Very good. And now, I can do three things that you already know how to do. I can solve the quadratic equation by factoring. I can solve it by using the quadratic formula, or I can solve it by completing the square. I'm not going to start using all three methods because it's going to take mad long, right? So, let's try to factor, see if it works. Okay, first I see if there's a greatest common factor. I found out that there is none. So then I proceeded to open the parentheses. Let's see now, two numbers, okay, factors of 72, and I need a 1 in the middle. 8 times 9 is 72. So 9 times 8 is 72. I need a positive 1, so I do the smiley face to get the middle term. And I need a positive 1, so this is going to be positive, okay, 9x minus 8x, so boom. Now this is equal to 0, so I have to set each factor equal to 0. So I set them equal to 0. X plus 9 equals 0. And x minus 8 equals 0. I solve for x, and I get x equal to negative 9. Okay? And x equal to positive 8. Now, is this the end? No! You still have to find your y values. So, let us find our y values. How do I do that? Easy. Take each of the x's and replace it into one of the equations. I am going to take the easiest equation, which is the linear, okay? I'm going to take this linear equation and I'm going to replace my values. So I'm going to copy the equation down here so you could see it, okay? Y equals to negative 12x, okay, plus 36. That's the equation, and I'm gonna replace each of the x values that I found. So x is -9, so when x is -9, I get y equals -12 times -9 plus 36. And here, if I replace 8, I get y equals to -12 times 8 plus 36. And now all I have to do is use the calculator to calculate what's going on. All right, so what is -12 times -9? 108, right? Plus 36? $144. Okay, and now what is here? Well, 12 times 8 is what? 96, right? So this would be -96. All right, -96 plus 36 is -60. All right, so now to state my solution, so you write solution. Okay, when x is -9, y is 144. When x was 8, or when x is 8, y is -60. And that is your solution to your system of equations by using the substitution method. Okay, let's have the same equations, right? Or you know what? No, let's have the same one and use a different method. All right, this is called the elimination method. So you write down both equations, solve for y. In this case, they are already solved for y. You see that? So you write them down. So you get y equals x squared minus 11x minus 36. And the other one is y equals to -12x plus 36. Notice how I lined up the like terms. I really don't want to confuse you this time. And now just, well, is there a square term here? No, it's 0x squared. Got it? There's nothing there. So that's why I didn't write it. All right, so now just subtract them. That's all. Really? Let's try it. Y minus y, 0. Oh, wow. Okay. X squared minus 0x, x squared. -11 minus -12 is the same thing as -11 plus 12. Plus 1x. -36 minus 36. -72. And now your equation is equal to 0, just like this one, okay? And you have the same things over here. So the next process is the same. You factor, okay? You equal them to 0. You substitute into the equation and you get your solutions. All right, so now you know two methods. It always works. I hope so. Now the last method. Sometimes it works fine, sometimes it doesn't. So the last method is the graphing method. So what I'm going to do is I'm going to create a set of axes. All right, so I'm going to have to make this a little smaller so you could see better. So I create my axis. First of all, I want to know what my solutions are algebraically. 8, -60, okay, and 9, 144. So basically, I need 144 on the y-axis and I need -60 on the y-axis. Oh my God, I hope you can see this. Very good. So I am going to create my y-axis has to be very, 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 very large. Okay, like that. My x-axis doesn't have to be that great because it doesn't expand that much. But let's see now. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's gonna go from here. Okay, I hope this is good enough. Now I need a scale, right? Wow, I need a scale. And now I'm doing this scale because I know what's going on. But in reality, call upon your best friend. All right. So press y equals, erase everything that we've been doing on the last session, and we are going to grab our equations. So let me write down what the name of our equations are. we have right here, we have y equals x squared minus 11x minus 36. And we also have y equals negative 12x, okay, plus 36. All right, we have them right there, and we are going to graph them with the graphing calculator. Kobe, stop running. All right, so y equals, and then x squared minus 11x, okay, minus 36. So I graph, and that's what it looks like. Come back. Didn't come back? Okay, cool. Now let me graph the second one. Negative 12x plus 36. And I look at it, and I still don't see anything. All I see is two lines going like that. So guess what? I need to adjust the window in my screen in order to understand. The window only has negative 10, positive 10, positive 10, negative 10. What do I know? That the x values are okay, negative 10 and 0 to positive 10. But the y-axis needs to be adjusted. All right? So my x and my x's are okay, the scale is okay, but the y minimum, I need a minimum of 62 at least, okay? And the maximum, well, I saw when I did algebraically that my solution was 144, so I need like 148. Now watch what happens. Oh, look, I think I needed more. So you see, I got that. I could make the y minimum even larger. The y minimum, I could make it negative 180. Okay, so what happens now is that you may be able to see the whole parabola. All right. So I have this right here going, and they intersect right there. So let me make the x a little more viewable. So window, the x maximum, let's make it 20. Let's see what's going on now. Ah, you see that? So it's all about playing with it. All right, so this is the system of equations, and they intersect in two areas. Now we want to know where do they intersect. Well, there are two ways of doing that, but first let's graph them. So what do I know? I am going to first graph the parabola. Let's graph the parabola. So the blue one is the parabola, the red one is the straight line. So what values do I need? All right, I go 12, 24, 36, 48, 60. Interesting. The red one is the parabola. No, the red one is the, oh my God, I was so happy. The red one is the straight line. The blue one is the parabola. So I need values. Where is the turning point over here? It seems that the turning point happens somewhere in here. All right, so to graph them, I'm gonna have to find the vertex. I am not going to turn this into axis of symmetry vertex form. I just need to find the vertex. So the vertex is found by doing the following. I gotta do what I gotta do. So the vertex, oh my God, how do I do this? Oh, right here. The vertex is known as negative b over 2a. That's the axis of symmetry. That's where the parabola changes directions. Like it goes, is the turning point. Or what splits the parabola in half. So the axis of symmetry, negative b, so that will be the negative of negative 11, so that will be positive 11. So 11 divided by 2 times a. In this case, a is 1, so 2 times 1 is 2. So at 5.5, the parabola is going to be chopped in half. Now to find the y, all I have to do is substitute this 5.5 in here. Okay? Or I could just go and no, that's exactly what I'm gonna do. So this is very difficult. Why am I making it so difficult? I don't know. So let's see now. 5.5 squared minus 11 times 5.5 minus 36. And it's negative 66.25. So negative 66.25, that's the vertex. Okay, so now I know that. So 5.5 comma negative 66.25. So negative 66. Now I need to create a what do you call that? A scale. So how am I gonna create a scale? Well, let me go by on the y-axis. Let me go by by 12s. 12 should be fine, right? Let me see. 12. Man, this is hard. Okay, so by 12. So this is 12, 24, 36, 48. Okay. What's the next one? 60. 36, 48, 60. Okay. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 should be 120. 1, 2, 3, 4, 5 should be 180. Okay. Now 0, right? Sorry. 0, 12, 24, 36, 48, 60, 72. Okay. 72. 84. 96. Okay. 108. 120. Yes, it works. All right. Now down here. So I got negative 12, negative 24, negative 36, negative 48, negative 60. Okay. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is negative 120. I don't think I'm going to need negative 120. Okay. So now I am going to start graphing. Let's graph the parabola first. I'm going to graph the nice numbers. I cannot graph anything that is not. So let me start at negative 6. So negative 1, 2, 3, 4, 5, 6. Actually, let me start at negative 10. Negative 9, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 comma 144. Negative 9 comma 144 right here, the parabola. So 144. So this is 120, right? Then this is 132. Okay. 130, no. 120, 132, 144. So this is 144. Okay. This is 144. Can you even see it? No. Okay. This is 144 right here. Sorry. Okay. The next point that I'm going to graph is negative 8, comma, 116. So negative 8 and 116 should be around here. Okay? Because this is 120. So, and this is 108. All right. And now I'm going to graph negative 7, comma 90. Okay. So this is 72. This is 86. Okay. As we got to do this 72. 84, sorry. 84. Okay. 7 comma negative 7 comma 90. Negative 7 comma 90. Negative 7 comma 90. 90 should be what? Around here. Okay, because this is 96. All right. So now I understand everything. All right. The next one will be negative 6 comma 66. Okay, negative 6 right here comma 66, which is 66 should be around here, I guess. Okay. Or not. Let me see. Something is not right. Negative 1, 2, 3, 4, 5, 6. 66. Okay, whatever. Oh yeah, I know what's not right. Negative 7 is 90. 90 is right here. So this point doesn't work. Okay, no wonder. All right. Let us move on to negative 5 comma 44. So negative 1, 2, 3, 4, 5 comma 44. 44 should be, this is 36. Oh my God, who's calling me? Okay, sorry, no can do. Somebody was calling me. All right. Negative 5 what? 1, 2, 3, 4, 5. Okay, negative 5 comma 44. 44, this is 36. So what's the next number? Okay, 36, 48. So 44 should be around here. I hope so. All right, negative 4 comma 24. Negative 4 comma 24 right here. That's the first nice point. Negative 3 comma 6. Okay, so negative 3 comma 6 around here. Wow, let's graph 2, 0. Let's graph 0. 0 comma negative 36. 0 comma negative 36. 0 comma negative 1, 2, 3. Okay, 36. 12, 24, 36. All right, let's graph another point that is big. 3 comma 60. Because I'm getting tired of this. 3 comma 60. 1, 2, 3 comma 60 right here. Wait. Oh yeah, negative 60. Next point. Let's try 8 comma negative 60. 8 comma negative 60. 1, 2, 3, 4, 5, 6, 7, 8. Okay, comma negative 60. Oh my God, 1, 2, 3, 4, 5, 6, 7, 8, comma negative 60. Okay, so now let's try 9 comma I don't know, 10 comma 46, negative 46. So 10 comma 46. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 comma negative 46. Negative 46. Well, this is 12, 24, 36, 48, 46 around here. Okay. Let's try 12 comma negative 24. Okay. 12 comma negative 24. So this is 10. This is 12, 24. All right. So that's it. Now let me graph the vertex. Oh my God, this, I didn't know this was gonna be so hard. Negative, it's 5.5 comma negative 66.25. So it's 1, 2, 3, 4, 5, 5.5 comma 66, negative 66.25. So somewhere in here. All right, so you see how difficult it was, but look, the shape of the parabola don't lie. So we start right here, okay? Yeah, it's gonna look crooked, but hey. And of course, the behavior is gonna have some type of weird behavior. But the purpose of graphing this, it was very long, and I'm gonna have to edit some of these parts. But the purpose is to show you that not everything is perfect. You have to create a scale, okay? Maybe on the regions, they're not gonna ask you such a difficult for such a difficult graph, but still keep that in mind. So we just did a scale, we created the parabola. Now let's graph the linear equation. The linear equation is actually very easy. Okay, that's the red one. You can look at the table of values. I really don't have to look at the table of values because we already know how to graph linear equations. We look at the slope, we look at the we look at the y-intercept, and we're good. So look at this. The y-intercept right here is what? 36, and the slope is 12 over 1. So what that means is the following. I'm going to start at 36. So 36 is right here. Okay? And now I'm going to go 12 down and 1 to the right. Oh my God, maybe I need a different color. What do I have a different color? I need the green one or the black one or the whatever, because I need to show my fans what's going on. Oh, okay, I found it. So once again, 36 is the y-intercept, so boom. And now I am going to go 12 down and 1 to the right. Now listen, 12 down doesn't mean 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here, because we already have a scale. Every time you go 1 down, actually you're going 12 down. Please try to understand that. You see, that's why this exercise was a very good exercise. So 12 down, so that means 12 down and 1 to the right. Remember the scaling of the x. We never scale the x to more than what it had to be. The scaling, it goes by ones. So the scale factor is 1. Okay, 1, 2, 3. So we're good. 12 down and 1 to the right. 12 down and 1 to the right, 12 down and 1 to the right, 12 down, 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 1 to the right, and we have our thingy. Now guess what? We saw on the calculator that it intersects twice. So let's see. Down to the right, well, 12 up and 1 to the left, the same behavior, remember? Oh my God, no, please tell me. Oh, Jesus Christ. Oh my God, yes, it does. Let me make it a little smaller. We are going to graph this line. I don't know how it's going to be, but we did a great job right here. All right, so it's gonna be right here. I'm gonna graph the first part. Okay, and the second part. Jesus Christ. And there you go. Woo! Really? 2 hours for one exercise? All right, so we have it. We have the points of intersection. Okay? We have this point of intersection, which is basically 1, 2, 3, 4, 5, 6, 7, 8, comma, negative 60. Okay? And we have this point of intersection, which is negative 9, comma, 144. Right? These are your solutions. So this is the other way of doing it by graphing. Now, is it always going to be this difficult? Of course not. Now, remember, you got this beautiful partner with you. So if you ever in trouble, remember, all you have to do was create a scale factor. So you turn it on, you look at your numbers. Okay, look at the graph first to see what it looks like. Okay, now once you have a better, if you cannot see your graph, you need to adjust the window. As simple as that. X mean X man, just sideways. Y that are up and down. You look at the graph, see what it looks like, see where they intersect, and you already know how to use the calculator. If you want to find the point of intersection, you go second calc, and what do you want? Intersection. Yes. Of where? Well, left boundary, I want to find this intersection. So I go to the left of the intersection, enter, okay. Then I go to the other one and look, this is the second graph, okay, intersection. What is it? 8, comma, negative 60. All right, now we want to find the other intersection. Sure, second, calculate. What do I want? Intersection again. But this time, we're gonna go all the way over there. Because when I get close to what we want. Okay, intersection, yes. Second curve, right there, yes. Guess, yes. And it tells you, look, negative 9, comma, 144. Got it? All right then. So that is how you do a system of equations by elimination, by substitution, and by graphing. And you know what? Let's do another one because we still are not done with this. All right, move with this and continue with this. Let's have another example. Oh, okay, so let's see. Let's solve this one. Y equals x squared minus 4x minus 1. That's the quadratic, and this is the linear. Y equals 3x plus 1. So let's use the substitution method first. Okay, we're still gonna use all three methods for this graph. I didn't know it was gonna take that long, but let's do it. All right, so substitution. I'm gonna take one. Both equations are solved for y, so I don't have to do anything. But if they're not, you have to solve for y in the quadratics and in the linear. So you could substitute one for the other, or just solve one of them for y and substitute into the other. So I'm gonna get this one over here, and I'm gonna substitute y. So I get x squared minus 4x minus 1 equaling 3x plus 1. Okay, so now I gotta make one side equal to 0 because this is a quadratic equation. So I'm gonna make this side equal to 0. So I'm gonna subtract 3x and I'm gonna subtract 1. So I get x squared minus 4x minus 1 minus 3x minus 1 equal to 0. All right, if you wanna figure out what I did, I subtracted 3x and I subtracted 1 from both sides, and according to the like terms and all that. I'm not gonna do that because I don't want to waste your time. Now add the like terms. So x squared, negative 4x and negative 3x, that's negative 7x. Negative 1 is negative 2, 0. Alright. Something is not right in here. Interesting. This equation right here, I don't think it's going to be solvable by factoring. So it's going to require a little more effort. But you know what? It don't matter. We are still going to do it. Alright, so how do I do this? Okay, minus 4x, minus 1, 3x plus 1. Alright. So, how do I solve this? You know what? I'm going to solve it. I'm not going to use the quadratic formula. I'm going to use complete the square method. So, this is what I have, and I'm going to solve by completing the square. So how do I complete the square? Well, easy. You move the loose number to the other side, okay? Then you take half of the linear term and square it. So half of 7 is 7 over 2. Squaring it is 49 over 4. And you add it to both sides, okay? Cool. Now you turn this into a perfect square trinomial. Into a square binomial. So this is x, okay, minus 7 over 2 square equaling. Okay, so what is 2 plus 49 over 4? Well, this turns into 8. So 8 plus 49, that is 57 over 4. I turned this into 8 over 4. Okay, so 57 over 4. And now we square root both terms. So I get x minus 7 over 2 equaling to the square root of 57 over 4. Alright? Plus or minus. And now to solve, I get x equals, I add 7 over 2 to both sides, so it's equal to 3.5, okay, plus or minus. Alright, so let's do numbers in here. Plus or minus the square root, okay, the square root of 57, okay, is that, so plus or minus 7.549, okay, and everything divided by 4. So what's gonna happen? I'm not gonna do any more. What's gonna happen is that you're going to find 3.5. okay, yeah, I'll do it for you, but just to the part where I get the answers. All right, so let's see, 3.5 plus 7, or actually no, plus the square root of 57, okay, is that divided by 4 is that. So x equals to 2.76. All right. And now let's do the other root, the minus. So all I gotta do is boom, boom, boom. So now 3.5 minus the square root of 57, and that is negative 4, and then we divide by 4 because that's what it says over here, and we get x being negative 1.012. That's as much as I'm gonna put 0.13, let's say. So now to find the y value, you substitute this into one of the original equations and you find it. All right, let's do another one. This was kind of like difficult, so, and by the way, yes, we're gonna do the subtraction method, but not on this one. I thought this was very good, very good. And let's try a different one. Let's try this one for size, because really we want to do something easy for you so you can understand it, and then we'll jump into the difficult stuff. So this is the quadratic and this is the square. Really? No, sorry, is it too long? Okay, so this is the quadratic and this is the linear. All right, so substitution method, I put this one in here because it's already solved for y. So I write x squared minus 6x plus 3 equaling 2x minus 13. All right, and now I set one side equal to 0. So this time let's do this mentally. So I'm going to subtract 2x, so it goes over here. So negative 6x minus 2x is negative 8x. Then I'm going to add 13. So 3 plus 13 is 16. And I made this equal to 0. Now I'm going to see if I can factor. If not, I'm going to have to use the quadratic formula or completing the square. But hopefully I can factor. So now, factors of x squared, x and x. Factor of 16, 4 and 4. Negative, negative. Negative times negative is positive. Negative plus negative is negative. Equals 0. The solution is x equal 4. And oh my god, x equal 4. Oh, cool. All right. And now to find your y value, you substitute each of the x's, of course, is the same. So into one of the originals. Let's do the linear one. So I have y equal 2x minus 13. And now when I substitute the value, I get y equals 2 times 4 minus 13. And now I got y equals 8 minus 13. And I got y equals, well, what is 8 minus 13? Come on. There you go. Negative 5. Making your solution 4, negative 5. And let's see if it's true. But before we continue, let's do the subtraction method on this one, because we're trying to do the easy ones, and then you might get into difficult ones once you have the idea. So the subtraction method, all you have to do is basically write the two equations, solve for y. Okay, you write them down for y, and then you subtract them. That's it. So let's see. Subtraction method. I call it like that, or you could call it the elimination method. So y minus y is 0. There's nothing to subtract from x squared, so it's x squared. 6 minus 2 is negative 8x. 3 minus negative 13 is positive 16. And there you have it. Now this one, it's already looking like this one right here. And from there, you just know what to do, right? Cool then. Now let's use the graphing method. Okay, graphing method, here we go. So the first one was x squared, all right, minus 6x plus 3. There you go. And the other one, it's going to be 2x, all right, minus 13. That's it. Now let's graph them. Now look at what the graph is going to look like. All right, so what's going on here? Well, what's going on is that we have too many y values. Remember that I didn't reset the window, so I'm going to reset it right now. Solution is 4, negative 5. So let's have the default values. Negative 10, positive 10, negative 10, positive 10, and graph. Now it should look better. Ooh. Ooh. Look at that. The line only touches the parabola at one point. Let's see, where do they touch? Whenever you do something algebraically and you get a nice answer, you can just look at the table here. All right, look at 4. When x is 4, the blue one is the parabola. Okay. When x is 4, the parabola, the y value of the parabola is negative 5. All right, so what does that mean? Well, look again. When x is 4, the y value on the linear equation is also negative 5. That means that at that point, they both are 4, negative 5. Therefore, that's one of the solutions. That's where they intersect. But of course, if you're looking at that, you could just press second, calculate, and find the point where they intersect. So what do you want? The first curve? Yeah, sure. On the blue one, boom. The second curve, the red one? Yeah, sure. I'm close enough to the intersection? Yes, okay. So where is it? At 4, 5. Sorry, 4, -5. I cannot see, I'm blind. All right, cool then. So that is how you solve system of linear quadratic equations. Let's try one just for the sake of trying it. It's gonna be a long one, but might be worth it. All right, and we are going to use the substitution method, and then I'm gonna show you what's gonna happen. Cool. All right, the equation is x squared minus 6x plus 3. And the other one is y equal 2x plus 1. All right? So, this is what happens. Let's do the subtraction method, which it's already set up for that, okay? So this is 0. There's nothing from the x squared, so it's just x squared. Then negative 6x minus 2x is negative 8x. And then 3 minus 1 is 2, so like that. There you have it. So what am I going to do? I'm going to try to factor. Now, I know it's not factorable, okay? If this number is bigger than this one, I mean, I cannot factor right now. So I already know that I could either complete the square or use the quadratic formula. So I'm going to use the quadratic formula to show you something. The quadratic formula is the following. Negative b plus or minus the square root of b squared minus 4 times ac over 2a. So let's have the values. The coefficient of a is, the coefficient of x squared is a, so is 1. The coefficient of the linear term is b, so negative 8. C is the constant, which is 2, and negative b is the opposite of b, which is 8. Okay, so now let's substitute into the quadratic formula. So negative b, so that will be 8 plus or minus the square root of 8 squared minus 4 times a times c. All right, so that's what we have. Okay, so this is a over 2 times a, which is basically 2 times 1 is 2. So let's see now. This is 8 plus or minus. All right, so we got 6. Wait, hold on a second. Oh my God, I made a mistake. Well, doesn't matter. So 64. This is actually nice. 64. Now negative times positive, negative times positive, negative. So 4 times 1 is 4. Times 2 is 8, so it'll be minus 8, okay, over 2. Now we have 8 plus or minus the square root of 64 minus 8. What is 64 minus 8? 56, right? So 56 over 2. All right, sorry, this is x equals, remember? So now I'm not gonna go any further because I thought this was one of the equations that didn't have a solution, but I guess it does have solutions. So I'm just gonna tell you what's gonna happen, what you gotta do right now. So you're gonna do 8 plus the square root of 56, and you're gonna divide by that by 2, and you're gonna get your x. Then you're gonna do 8 minus the square root of 56, okay, you're gonna get your number, and you're gonna divide by 2. Those values you're just gonna substitute into one of the original equations to get your y values, as we've been doing. All right, you want me to graph them? Sure, I could graph them. So this is x squared minus 6x plus 3. Let me zoom in. Oh, okay. And this one is gonna be 2x plus 1. Oh, okay. It was still not factorable, but let's see. Now let's graph. That's your parabola. That's your linear. And as you can see, they will intersect twice. So they have a solution. You could just go a second calc and calculate the intersection points, and those are your solutions. So there is no harm done in me not finishing up this problem, because I really want to do the one problem that I was talking about. I thought it was this one, but I guess it's not. So let me try again, and this time I'm going to try to copy as nice as possible. So my first equation is going to be y equals to x squared minus 6x plus 3. My second equation is going to be y equals to negative 2x minus 6. All right? So again, we could do the substitution, this into this one, then set this one equal to 0, or just use the subtraction method, as long as they are lined up and equal to y. So y minus y is 0. X squared doesn't have anything taken away from, x squared doesn't have anything taken away from it. Negative 6 minus negative 2 is negative 4. And then 3 minus negative 6 is 9. All right. Now this is not factorable, because I'm telling you to. I'm telling you so. It's not factorable. So I want to use the quadratic formula. So we already have the quadratic formula right here. So I'm just going to find out what A, B, C, and negative B are. Okay, so A is the coefficient of x squared, B is the coefficient of the linear term, C is the constant, and negative B is just the opposite of B, so that will be positive 4. Now let me replace into the quadratic formula. So negative B plus or minus the square root of B squared minus 4 times A times C. Okay, now that I have it set up, I'm gonna zoom in. Okay, everything divided by 2A, which is 2 times 1. All right, so 4 plus or minus, that's it. Negative 4 squared is 16. Now, negative 4 times 1 is negative 4, times 9 is negative 36. Everything divided by 2. Then we have 4 plus or minus the square root of, what is 16 minus 36? 20. So negative 20 divided by 2. So I'm going to tell you right now. Let's stop right here. This inside the quadratic, the square root is called the discriminant. What? It determines whether you're going to have solutions or not. So look, I have the square root of negative 20. I'm just going to do it. Square root of negative 20. Square root of negative 20. Error. No can do. You cannot do that. In real mode, all calculations result in real numbers. What does that mean? Can't do it. Error. You cannot take the square root of a negative number. Look. Let's take a look at the square root of 9. Okay, the square root of 9 is supposed to be 3, positive 3 or negative 3. The square root of negative 9. I mean, how in the world? Look, negative 3 squared is going to give you 9. 3 squared is going to give you 9. So you can only take the square root of 9. There is no number that when you square it, you get a negative, there is no number that when you square it, you get a negative. So then when you take the square root of a negative, it's not going to give you, there's no number. Okay? Nothing squared is going to give you negative 9. So therefore you cannot do this. So then if you cannot take the square root of a negative number, then there are no solutions. And now I'm going to demonstrate, thank God, thank you for this problem. I'm going to demonstrate on the calculator. I'm going to graph them. Now, no solution. What in the world does no solution mean? Well, let's take a look. All right, boom, clear, boom, clear. So x squared minus 6x plus 3. Here, 2x minus 6. Let's graph. Let's see what's going on. Yeah, those are the graphs. Exactly. Whoops. Did I do something wrong? X squared minus 6x plus 3. Oh yeah, sorry. This is supposed to be negative 2. So negative 2x minus 6. All right, please, come on. I mean, think I'm wrong. All right, let's look at it again. My God. Please. Oh, good, nice. Look. So you saw what happened, right? Look, the parabola is right here. And this line, they don't intersect. They don't touch. There's no intersection then. No intersection. So you cannot find a solution. Got it? All right, good. So you can have two solutions, one solution, no solution. All right? And I told you now, algebraically, when you have no solutions. Thank you very much, and I'll see you on the next episode of How Do We Pass Our Common Core Algebra Regions, and we are going to start working on the regressions. Bye-bye.